the one I've been telling you about, with point slope form. The only time you use this is when I told you so, or the test tells you so, okay? It's not used to do graphing. It doesn't help you with graphing all that much. We just use it because they tell us it should be in point slope form, okay? So if you think about the word for it, just like slope intercept, you were filling in the slope and the intercept in point slope form, you'll still have to fill in the slope, but you'll also use one of the points, okay? So in this first one, it says developing the point slope form. So it's kind of fuzzy. Write an equation of the line that uses the points 2, 5 and x, y. Okay, now they tell me my formula. Here I have it. Oh, okay, here I have it right down here. It's pretty small there, so I'm going to rewrite it for you. We're going to write y minus one of the y's equals m, and then it's going to be the quantity x minus one of the x's. That's point slope form. Now, what you're going to be filling in here is you're going to fill in this, you're going to fill in this, and you're going to fill in this. So kind of similar to slope intercept, you're still going to have just a plain old y and a plain old x, but you're also going to know one of the points. It doesn't do you any good. It doesn't show you the y-intercept. It just is in this form. So in this form, it says that I have the points. I'm going to rewrite this too because I know some people can't see it back there. And I don't want to mess around with magnification and screw up our calibration. Listen to those big words again. Alrighty. So our 1 point we really don't know, basically is what they're telling us. And we want one of our points to be an I don't know one in our final equation. So the one thing I have to figure out is how am I going to, in this case, I want to make sure I'm not jumping ahead. I want to follow what they have here. So if you refer to the book, you're in the same place. It will make sense to you. Okay. So what I want to do here is it's telling me, when I look here, and this is going to be real hard for some of you to see, but this rise, it's at 5 and it's going to 7. So it's telling me that I'm rising up 2, and then can you see on this one, I'm going to run 3. Okay, so the graph here is giving me my slope. Do I need my slope? Yes, in the equation I need my slope. So what I'm going to do is I'm going to go back to my black because I'm doing business here. All right, this is going to say y minus, and I have to choose one of my points. Well, it only tells me information for one of it. So I'm going to say y minus 5 equals the slope that I saw here, which is, they're both positive, and it's rise 2, run 3. Then I'm going to put my x minus my x that is given. That's point slope form. It's just following a formula and plugging in the information. Now, be careful, and I think the next one, probably just look in the book. Yeah. Okay, so my next one, it says you can use the point slope form when you are given the slope and a point on the line. In the point slope form, x1 and y1 is the given point, and xy is any other point on that line. So again, you can see this one a little bit better. What we're going to fill out there is we're going to fill out this, this, and this. Now you can't see it though. So it's y minus y1, that's going to be a value, equals m, that's going to be a value, times x minus x1. And this is going to be a given value. Okay? So in this one, I'm having a really hard time seeing the glare of it for me. In this one, they're giving me the point -3.6, and they're giving me the point 1, -2. I could go ahead and rise and run, or I could go ahead and use the slope formula, whichever one you feel more comfortable with. Visually, if they give you a graph, that's supposed to be the easiest one, but sometimes you guys make mistakes with that one. So you can still use the formula anytime you want to. But for this one, we're going to rise, and each line is 1. We're going to rise 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I'm at 1 here, and I'm going to go, this one's going to be a little bit harder to see. 1, 2, 3, 4 to get to -4. Okay, so if, just looking at it, I could say my slope here, that's because of my snowman. My slope is, I went up 8, I ran a -4. Okay, so what's my slope? My slope would be, what would it be? -2, because you could either write it like this, and then, all right, now I have all the information I need for point slope form. I have one of the points. I actually have 2 points. Okay, so this one, this is so much fun because it can have 2 separate answers. So my one answer could be y minus, make sure you go to the y coordinate point. Which one do you want to start with, the blue or the red? Blue. Gee, thanks for that. We'll start with the blue because I'm writing in blue. So y minus, my y part of this coordinate point is a -2. So what's y minus a -2? Y plus 2. Never give me 2 symbols. So even though the formula says y minus, make sure you're using your integer rule. Y minus a negative changes to y plus. All right? Put in your slope. X stays the same, minus the x value, which is 1. So it's going to say x minus 1 on that side. Everybody understanding that? All right, let's go. I'll do it in red, just to match our red point. So again, y minus, what's my y on that one? So it's going to say y minus 6 equals, slope is going to be the same. That's the only nice thing when I'm correcting. The slope has to be the same. All right, x, and then plus 3, because it would be minus a -3. Point what form? Okay? All right, look good so far? So if they do not show you this, if they don't show you this, we'd have to figure out our slope. So we could have taken that, and I'm going to just use it this way. I'm going to say m equals, and we'll do -2 minus 6 over 1 minus a -3, so it's 1 plus 3, and we still get a -2 for our slope. So either count it out if it shows you a graph, or use the formula to find slope, which is what you were doing in 5.1 through 5.3, right? If they gave it to you, hey, that's easy, I'll just plug that in there. If they didn't, but they gave you 2 points, figure it out. But they have to give you 2 points. That would not have worked for this one. They couldn't have just given you this information here and no graph and said, figure out the slope. You can't, because you don't know what that other point is. On a graph, you could have at least found a nice intersecting point and figured out. But if they're not giving you a graph, they have to give you 2 coordinate points. Yes?
So, when you have your 2 coordinate points,
Mm-hmm.
do you have to make 2 separate equations and do, like, each of them? Like yeah. Do you have to do both of them?
No. Either one of those is the correct answer. That's why it's so fun for me to correct. You know, it's better to give me a million things to correct, right? So you know the formula. I would maybe circle, and I know you can't circle on your notes, but know that maybe just put a note. You're going to fill in the y1, the m, and the x1. Okay? All right, moving along then to the next one. So modeling a real life situation. Really hard to see. I'm trying to get to a good place that I can see some of this. Which one did I do here? The thermometer one. I guess that's the only one in here. So again, we're going to look for the slope. We need to know the slope, and then we need to know one information on the X and Y axis, right? So notice, because it's real life, they didn't give me a graph, sorry, that little green part there. But real life, I always have it like this, right? And so we can find the rate. Our rate is going to be our M. This says, I guess we could read this first. It says, the information to the right was taken from an article that appeared, I can't see that part, that appeared in a newspaper. Okay, so it says temperature affects running speed. I have a couple runners in here. The best temperature for running is below 60 degrees Fahrenheit. If a person ran optimally at 17.6 feet per second, he or she would slow by about 0.3 foot per second for every 5 degrees increase in the temperature above 60 degrees Fahrenheit. Okay, so that's your everybody's best running is supposed to be at 60 degrees Fahrenheit. So it says in my first part, use the information to write a linear model for optimal running pace. So to do that, we're going to have to figure out what our rate's going to be. So we're going to do for that, we're going to do the change in our pace over the change in our time. Okay, you can see that here. All right, so over there it said our change in our pace, and I know you can hardly see this, but if you go back to the recording, you'll be able to see it too. Whoops, that's not good. It says we go 0.3 per second. So that's going to be our change in our pace. And we're going to make it a negative because slowing down or getting faster. If a person ran optimally at 17.6 feet per second, he or she would slow by, okay? All right, now we want to do our change in temperature, okay? And the change in temperature that they gave us was, I'm trying to find it on my board here, 5 degrees increase. Oh, yeah, it's over here. 5 degrees, I'm looking over here. 5 degrees increase. Oops. So that's going to be so that's our slope. That's our rate. And if we're going to, I'll go ahead and I'll cheat here and look in the book. Oh, it even has it right here for me. So when I reduce this, because we're doing it in an equation here, so we don't have to worry about rise over run, okay, that's going to be my slope. Okay, everybody okay with that? We found our slope now. Now we have to find an x and a y. To find the x and the y, it told me that I would do 17.6 feet per second. Is that going to be my x or my y? If I was going to label this, how would you watch the change in this? Which side would be feet and which side would be seconds? Okay? Or I guess it should have been temperature, not seconds. Sorry, it should be temperature. We're talking about temperature, not the change in time. Change in temperature. Okay? Okay, and then feet, I guess I could say that maybe better. How about if we do pace? Does that sound better? Get rid of that. I don't want to mess it. Okay, so your x is your temp, and your y is your pace. So if you can read so microscopically, and I'll help you with that. So our point here would be 17.6. I'll help you. I'm not having as bad a time as you are. And our temperature was at 60. Good job. I don't know if that was memory or if you could see it. So now we have our x and y. We needed our slope, and we needed one xy point. So now we can put it in that silly slope and oh, I shouldn't put it in that, say that point slope form. So we have y minus. Y minus 7.6. Very good.
Equals
negative 0.0 times x minus 60.
Now that's point slope form. And it means absolutely nothing to you.
Yep.
As far as how to solve it. So in real life, what you probably would do is letter B says. Whoops, letter B says. Maybe I have it on the next screen. Letter B says, use the model to find the optimal
pace
thank you, pace at 80 degrees Fahrenheit. So what they did was they plotted some X's and Y's in there. So going back here, they would put in, and I would say you would probably put in this X to see what it would do to your output, like we always do. Okay, so they did some of those, and they got that lovely chart, which I was able to make that a little bit bigger for you. Okay, so they could say that you want to know your pace. You remember from the last screen what your slope, what your rate, what you were going to do, your rate of change? Okay, got it. And then we're going to say that we want to find out our temperature. Whoops, I have no idea what I did there. Oh, okay, I don't know what happened there. But our temperature, and this time they're saying at 80 degrees. Okay, and then we want to know, let's see, plus, where are they getting this part? Because we jumped ahead here. Where are they getting the 21.2? Did we mention anything about 21.2? Oh, I guess I skipped that other part that they put in. I'm skipping ahead. This screen we were just to fit in a little bit more than we did. So that's what's messing us up. So I'm going to do the magic here of Mimeo. I'm going to move this one down. Because the last one, if we would have put this one in a more understandable one. Because on word problems, you don't want it. There's no reason to put point slope in word problems. So when we took that point slope from the last one, if I would have went ahead and put my like terms together, so from this one here, if I would have put my like terms together and solved, I would have got to P equals, whoops, this is the part that we kind of skipped ahead on, and then it comes out plus 21.2. That's when I put all my like terms together and ended up putting it in this form. Okay, so this is our formula. Oops, this should have a T in there. Yes, I want to make sure I was using this. They use a capital T. So then that's where we put our 80 into there. Then we put our 21.2, and then we solve for our pace. And since the book already has it figured out for me, I'm going to cheat and say it's 16.4. You would have done it with a calculator anyway. Now, the main thing to think about that is when they're asking you point slope, again, you would take one of these points and use it as an X and the one X and the Y. So this kind of goes back to the one Grace asked me about. Do you have to do both of them? You don't have to do both of them, but you do have to have one or the other, whichever point you're going to choose. Okay, so let's go back to the very beginning. Your formula is Y minus the Y part of the coordinate point that you know equals the slope, whether you're given it or you have to figure it out using the formula, times X minus the X part of the coordinate point you're given. If you're giving two coordinate points, if you're given two coordinate points, I use the blue one in blue marker. The reason it's a plus 2 is because it would have been minus a negative 2, so we change it to plus 2. So we use the blue coordinate points. This would be a correct answer, but this red one would also be a correct answer using the red coordinate points. And as I said, the one thing you're going to notice is the slope should be the same because we're talking about the same line, just different points on it. There's not a lot of meat to this. It's more what's that information and then plug it into this. It's not used for graphing. It's just how do I write it in point slope form. Yes.
Can you go back to the first slide? I got my notes for all of them.
Okay. And then I want to see if we can get just a couple on your worksheet so that you see how we do those. Yes. No, this is solving. Putting in point slope forms. That's it. That's it. Yes. Okay.
Sure.
I kind of covered when I was sloping here, I kind of covered.
When
the
I was
point you were
sloping.
given was 2.5.
When I was.
I'm kind of
That is recorded, but sometimes you don't listen to me.
Grace
Grace
Herbert.
Herbert. Honest Grace
Catherine
Herbert
K. Herbert.
sometimes doesn't listen to me. All right, so I'm going to go ahead and stop the recording unless there's a general question that we want on here for reference. Don't overthink this one is what I'm telling you. You need to have a point, 1 point at least. You need to have 1 point, and then you need to have a slope. So it's very similar to 5.1 and 5 through 5.3. You needed a point, you needed a slope. It's just where you put it and the order you put it in for this form, point, slope, form. All righty. Ways.